So our alpha system for the KARNO was about 125 kilowatt system. And if you think about that in terms of what it's replacing, sort of for the same size, that's on par from a power density perspective to sort of high energy density diesels or compression ignition engines or other spark ignition engines. But what we found through our testing is we could take it further. We found an opportunity within the exact same physical size and weight, we could squeeze out over 200 kilowatts out of the same package. And so between alpha and beta, our engineers set off to really refine and sharpen the pencil and kind of squeeze out those last percentages so that we could achieve this much greater power density where now, we believe we're one of the most power dense systems of its similar efficiency level.
Trying to keep the components the same shape and size means they're all going to have higher thermal loads on them. So any changes you're going to see as we transition from alpha to beta are trying to improve heat exchanger efficiencies so that we can push these parts even further than we did on alpha. So you're going to see things like thinner fins, higher fin densities, a lot of learnings in terms of, hey, on alpha, maybe these parts were separate and we're going to combine some of these parts because they seem like a good candidate to make them into a printed subsystem. Really just trying to tune in that fine recipe for transitioning between very thin wall structures and then bulky, mechanical structural members of the same part has been a big, learning curve here as we ramp up on beta.